Hello and welcome to Pretty Simple Fun. If you haven't joined me before, this stream is for building
Hello
a
and welcome
community.
to Pretty
Oh,
Simple Fun.
definitely did not mute myself. There we go. Uh, this stream is for building a community for game developers who work on hobby projects, kind of do stuff in their spare time. I've been programming games for about 20 years now, and a lot of it has been kind of on my own time. I only recently became a professional developer of video games. I did some other stuff before that. But yeah, so I work on these projects in my spare time and thought it'd be cool to kind of connect with other people who are doing the same thing. And so the like kind of sharing stuff on Reddit or Twitter is great, but you don't really build that connection with other people where, you can get investments and motivation from sharing what you're working on, learning from each other, that sort of thing. And so I'm hoping to build that here. So until we kind of get that piece started, what I'm doing is a couple of shows that I'm interested in. One of them is I'm just going to be working on my side project, talking to people about if they have any questions, that sort of thing, and working through just the code that I'm going kind of out loud, so that I can work on vocalizing my thought processes and not just kind of getting in my head and solving everything at once. Trying to get better at the teaching and mentorship aspect of programming. The other kind of idea that I have is for a stream that I'm going to do with my brother, where we're working on his video game, and he's going to be doing all the coding. We're going to broadcast from his perspective, and I'll just be teaching him basically, and kind of walking him through what he needs in order to accomplish what he wants in his game. So if you haven't seen what he's working on, it's a pretty cool elemental simulation game that does it's a little complicated to explain, but basically there's flowing water and heat transfer, and he wants to build a steam engine from component parts in simulation. It's got some shaders, it's got a bunch of, well, the graphics aren't super complicated yet, but mostly the shader code has been pretty cool to figure out. I've never actually done that before, so we figured that out together the other day, and if there's enough interest, I can put up. We did record some video from that. It's a little bit blurry because we used Discord's sharing or screen sharing, which just isn't super high quality. But I can definitely put it up on YouTube if anybody's interested in that. Just let me know. All right, and I think that's all the preamble. Let's just get into some code, shall we? I'm gonna turn on the music here so we can just hang out. So today, I'm gonna catch up from last time. We have this little game editor that I was working on, and what we built last time, which you can see the video on YouTube, is these little expression trees for the state machine here. So each of these little pieces is the expression that is going to be evaluated to determine whether or not the transition down here will be taken. And the part where I left off, so right now everything is just true, and there's not a very interesting expression. It's supposed to be based on triggers. So the transition after delay here is supposed to set a next trigger after 5 seconds, which I think it does. Pretty sure it does. We'll look at that piece because we're actually going to need this to work later. But what this should be able to do is it should be able to reference that trigger and say, hey, this expression evaluates to true if the trigger is set. And the way that the thing that I added in last time was this ability to create a tree of expressions. So what I'd like to do today is a couple things. I'd like to get each of these elements in here context menued so that I can add and remove them and create sub-expressions and change what they evaluate to, all that sort of thing. And then actually get this to function and compile down into the running version of the code. So for let's delete this transition right now. So just as a quick demo of what this code actually does, in case this is the first time you're watching, the up top here is a state machine, and on the bottom is data flow. So the state machine controls program logic, and the data flow just says, hey, these values should do these things when they change. So in this case, the state machine is going to enter here, and then the program is going to start executing. It's going to immediately transition, because this is a true. It's going to immediately transition to this state. And in this state, it says, hey, I want to set the clock variable to the current time. And then down here, it says, I'm going to read the clock variable and take its output and pump it into the Y position of this cube. So this cube over here, if we go into the scene, is just floating out in space. And if I run the game, then you see the cube rise because it's being set to the current time, and it'll just do that forever. So it's a super simple little test scene. We can do something much more interesting in the near future, but you kind of need the component pieces to work first. So one of the big component pieces is the ability to create these transitions. So let's get started. I want to first identify what rectangles I need to right click. Fortunately, last time I did the extra work of actually embedding all of this information straight down into the objects themselves. Oh, but that's right. So what I did in here is when this function, so there's actually two parts to this function. There's update expression positions, which does this somewhat convoluted two-part recursive function that first goes through and finds the sizes of everything, because the node's size in a tree. So if I walk down this tree here, just add some more stuff. So as you walk down this tree, the size of each of these nodes is dependent on its children. So you have to know how big the children are in order to know its size. And in fact, you also need to know how big the siblings are in order to determine your vertical placement. So this tree is bumped down a little bit because of how big this is. So it just takes a little bit of doing to get all that code to work. But the first part of it is to actually go and compute all these sizes and kind of bubble that data back up, since you need it from the children. And the second piece is to go from the top down and propagate that information down through the different nodes and actually bake in their positions. So what I'm going to need to do in order to create a context menu, let's make the first one delete, because that's going to be the easiest. Is basically I just walk through the expression. So let's go with the expression definition really quick. So in this expression, I just need to walk down through the tree and in here find this position rectangle and then just hit test it. So this is pretty straightforward, because all I need to do, where's my context menu? Okay, so here's the context menu section. So this is a function I wrote last time. This function is what allows me to click and drag this little piece here, which obviously we're going to make all this stuff look better, but right now I just want to get it to work. So we're going to do, why can I do this in the context menu? Can I actually write? Oh, right, that's what this is for. So if I right click that, then I can do this little add and, which is a total hack, but that's how it works right now. So we're going to do editor transition expression. So we're going to do this, not the anchor, because we actually want to get the expression in the tree. Now, is there a situation where the expression is going to want the transition that it's a part of? I might need to pass back two return values here, in which case I would change how this function signature works, but let's not worry about that for right now. Let's write this code assuming that this stuff works. And this statement here is starting to get kind of ugly. What I should do, rather than just kind of stacking all this stuff together, is make this should we do this? Yeah, I should probably make this a single pick, and then it returns a type, and then or returns success, and then if success, then check the type and do different pieces. But this is one of the things that I try to avoid is abstracting too much before I actually go in and like write the code that works. Because one of the traps that people fall into, and I definitely fall into this a lot when I was just kind of working on my own, was I would see some pattern in the system that I was building and say, aha, the thing that I should do is go in and abstract this. I should create a system that makes this easy. And as I've been programming more and more, I've kind of shied away from doing that, because often the abstraction locks you into a certain way of thinking about a problem. And if you abstract too early, you're kind of stuck. You can't think about it a different way given the code that you have. So you end up with these weird one-off, like, yeah, this works for, 95% of the code, but then sometimes, these 3 extra parameters that are optional, but some call sites need them because they do something exceptional. And to me, that's a failure of the abstraction, not of, they're usually not the, sorry, it's a failure of abstracting too early. So long explanation for why this if statement is so gigantic and is just going to keep getting bigger. So let's go down here. We're going to say else. Right, this is a priority thing, so I'm going to go here. If that's not null, then I'm just assuming, so this doesn't actually, it doesn't know the type of this yet because I haven't written the function that assigns it a type. But I'm going to just assume that everything works. Copy this piece, we're going to delete. So this is if we need to delete it, then you need to know its parent, which means that I probably need to, okay, so I could do this one of 2 ways. You can, in a tree, you can always know your parent, so I can add parent references to each of these. So over here where I have sub-expressions, each of the sub-expressions would reference its parent, and could definitely do that. Another option is I could just keep a reference to the editor transition, and that way I could go from the editor transition to the root, and then I could go through from the root and find all of the different, or like find it in the, sorry, I could find its parent in the tree just by searching the tree. Then I would know what its parent is. I could do both, because if you want to delete the root node, for instance, then, which doesn't make sense, but you can. If I wanted to delete the root node, then I would need to know the parent because I would need to set its reference to null. However, if you're the root node, then you don't want to be deleted ever, because then your transition won't work, and it's the same thing as setting your root node to false. So all I would want to do is just set it to false and never delete it. So I really only need a parent reference. The trick, though, is when you set up references like this, things get a little more complicated, because when this gets serialized, it's going to try to serialize the reference to the parent, which it can totally do, but it can end up being a little bit weird. It can end up being a little bit hard to follow. So another way of doing this, let me think here. Actually, I guess a third way of doing this that is kind of like the second that I described, where you have a parent reference inside of here, is whenever you pick this transition expression, you will also be given the transition. And so this way, none of the expressions need to know which transition they're a part of. You kind of always pass these 2 pieces of data together at the same time. And I think I like that one better, simply because you don't have to maintain as much. There's nothing to break. So, for instance, if you delete a sub-expression or you move an expression from one place to another, there's no need to update your parent references and make sure that all stuff stays in sync. There's no need to, if you weren't to serialize the parent references, then there's no need to rebuild them all when you load the program for the first time. And the cost you're paying in this case, or the cost that I'm about to pay, is in performance. Now, because you have to do a search of the tree every single time. However, that's not going to be an issue. I don't think it's going to be an issue. Because, so what I'm thinking is there's kind of 2 pieces of optimization here that I can do. One of them is I can keep the root node's bounding box and do the first hit test for picking on that. That way I don't actually have to go through the entire tree. And the second one is, I guess this is an optimization, but the second piece is these trees are small. They, we're not expecting a tree that's going to be gigantic. So if you pick something in here and then you need to go find a parent for it, that's not a big deal. In fact, I could just return the parent. because it's going to have to traverse the tree in order to find which one you hit anyway. So as long as it keeps its parent reference, then I could just kick that back. So let's just do that. That's easy. So I'm going to have editor transition with picked expression. So we're going to So what I'm doing is I'm just going to return these values. Picked expression. So this is just picked expression. Transition expression parent, and that's what I'm going to return. I'm just going to return it in its parent. And I guess we don't really need this bool because I can just assume that this is going to be the case here. So I can only pass one parameter to these functions. So it's going to be, I have to pass an array of objects and then just interpret it later, kind of like I did here. So editor transition expression index. Go back down to here, and we're going to plug this in. Save some typing. I don't know why I don't use var. I only use var for objects, not for value types generally. Is that true? Yeah, that's true. Even structs I'll usually call out. So this is, I can't call it params because that's a keyword in C#. The other thing I try and do is if I'm using var, I want the type to be super obvious. Usually I want the type to be obvious. So I'm especially comfortable doing it when I do something like this, where it's, hey, I'm taking this thing and explicitly casting it into this other thing. Right. Cool. So now I'm going to say editor transition expression parent. Remove that. I'm going to remove it at this index, and that should be it. I just need to write that, and away we go. Hold on, sorry. Dot sub expressions. Remove that. Okay. Cool, that actually does a removal, and then we write it to disk. I'm going to figure out how to cache this stuff better later, but right now it's just writing every single time. So, okay, so we wrote this assuming that this thing worked, which now we need to make this work. Right, I need to change this condition. So let's go pick some expressions. Transition expression. Graph position, and we're going to say, oh, right, this is, I like the form of this better, so I'm going to do it this way. I like returning that simply because it's the way that I've done it for the other ones. There you go. And this extra index is like a little add-on there, little additional context data. So, oh, but you know what? This is actually super unclear. No, I can't do it this way. I like how this looks better, but I can't do it this way because this is super unclear. The naming of this would assume that, hey, I'm actually going to be getting back the transition, but you're not. You're getting back getting back the expression, but you're not. You're getting back the expression's parent, and so it's much more obvious if you name that as an out parameter and do it that way, rather than trying to return it. So sad, not as pretty, but I don't know why. I've always been a huge fan of code that just looks a certain way, that has a nice, rhythm to it. I've often said that programming for me is just like language. It's like music. There's kind of a feel for it, and different people write in different ways. Condition expression parent. Okay, so now I get to make the choice again of, hey, do I traverse this graph recursively or do I do it using a work list? Now in this case, I mean, the recursive one is just so much easier to implement. Work list can be a little bit safer because you can catch things like infinite loops. So if somebody like me were to go in and stick a editor transition expression as the parent of itself or a sub-expression of itself, a recursive one would iterate infinitely without some additional safeguards, which you have to pass through a extra parameter, which makes it kind of heavyweight, and most of the time doesn't matter, but it's actually a trivial thing to add if you're doing a work list. The downside of the work list is that they're just a little bit harder to reason about, and essentially you're writing the stack yourself. So rather than using the call stack to keep track of where you are in the graph, you're writing your own stack, which is honestly not that hard. I did it already for the compilation piece. I'm just wondering if it's overkill here. It's because all we got to do is iterate, some sets of sub-expressions. So all I would have to do is store... I'd have to store 3 pieces of data, right? I would have to store, this is the expression that I'm looking at in order to do the hit test. This is its parent, and this is its index and its parent. We're in a pickle here, actually, because we need to return the expression itself. Or do we? So I'm thinking because the root has no parent, so it's going to return null, which is the same thing as not picking anything at all. So I do need to actually, there's going to be 3 pieces here. So both of those are extra data, and this one, so it is going to actually return this. This is getting a little more complicated than I intended, but that's okay. So on the plus side, it's a pretty satisfying little way to write this, because now we will always be able to do this. And in this case, we can say, hey, the delete is disabled. Disabled item, right? So if we don't have a parent, then we just disable the delete menu, which I do like that. It makes me feel weird about, this is just how Unity's UI is designed, but it's weird for me that this one function, which gets called over and over and over again to do layout and rendering and hit tests and interaction and all that sort of stuff, just allocates memory all over the place. I mean, this new GUI content is just everywhere. And I know it's not being called that much, like this is for a menu, but in other cases you do it for, hey, begin group, new rect. And I guess, okay, this isn't a good example because rect is a struct, but you get the point. Like, we're allocating memory all over the place in a function that gets called super frequently. So I would like to not do that, but it's kind of not set up to work that way easily. Again, little dissatisfying. Your transition expression parent. Why are you? Oh, right. These are expression type. In this case, I want var. Okay. Let's actually write this function, shall we? So, can you declare local structs? It's okay. It's already fighting me on declaring this, so I'm guessing no. All right. These are the items I'm going to add to the work list. And I really wish I could declare this locally rather than having to do it here, but that's okay. That's something I used to do in C++. So item equals new. So this is the first one. Yeah. So we're going to add the top one to the work list. And the top one's going to be our special starting point, where the expression is the root. So I'm gonna have to do this for each one. So I'm gonna do a work list clear. This is for each of the transitions. Go in here, add the transitions. Gonna add his root. This is dot expression. Thanks, IntelliSense. Parent is null because we're at the top. Index is doesn't matter. I don't have a transition expression index type yet. I don't think I really need one yet. I mean, I could have one just to, because something I talked about last time was how I use typed enums, or what are they called? They're just enums that derive from int like this, so that I don't get confused what an int means when I'm indexing into different arrays. And this is already saved some headaches and debugging and stuff. So I try to always do this, but I think it's overkill for this case because I'm not really using sub-expressions anywhere outside of the code that processes transitions themselves. So here we go. I'm going to start here. So index is -1, so that'll just be invalid. And of course the parent is also null, so it's like double invalid. Now we just say, so this is a trick I use. I declare a variable called sentinel and set it to some ridiculously high number. Come to think of it, we should actually set this to, yeah, you set this to the maximum number that you ever think. Let's just set this to dot. So I don't want to use max value because max value is really, really high and you can go through this for a very long time. But I mean, it's a pretty big number. So you say while work list dot count is greater than 0. So while there's stuff in the work list and the sentinel value is greater than 0, then keep doing this. And then we say, hey, if sentinel is 0, something got screwed up. And this way your program just doesn't freeze. And by the way, this is one of the few times that I'll allow myself to do this. So because Sentinel is kind of it's a debug thing anyway, so the code for it, I want to take up as little space as possible. So I usually don't do this thing where you decrement or increment or modify a variable and compare it in the parameter to another function. I just try to avoid that, especially in this case. So actually, let's do this. I always think that this is more clear because the way that I had, so if you all of course know post-increment, pre-increment operators. So this is a pre-increment operator, so it's a pre-decrement operator. It's going to decrement the value of Sentinel before evaluating this expression and before the while is evaluated, whereas otherwise it would evaluate it after. And I actually would have had a bug there because what would have happened is when the value of Sentinel was 0, which would cause this to be false, if I was using the post-decrement operator, it would have actually become -1, and the Sentinel equals 0 wouldn't have procced, and I would never have gotten this error, even in the cases where the Sentinel saved me. So I changed both things. So the logic's now correct, and also, if Sentinel is less than or equal to 0 is just safer than is equal to 0. Like, should never be less than 0, but, you know, people get sloppy, like I just did, and sometimes your code doesn't do what you think it does. So it's good to have these checks in there to kind of catch you. All right, back to the task at hand. So I'm gonna pop the first thing off the work list. And by first thing, so I can either do this first thing or last. I usually grab the last thing off the list because if you grab the first thing off the list, everything in the list has to move down a step. Especially, I mean, I don't know how list is implemented, but I'm pretty sure it's not using a linked list. I'm pretty sure it's just using a backing array because you can index into it. So if I pull off the very front, then that means that every time I pull something off, the whole list has got to move down, and that just involves a lot of extra copy. Copy is not super expensive, and again, we're working with small trees, so this doesn't really matter, but this is kind of just a habit thing. The only reason not to pull off the end of the list is if your traversal order matters, which in some cases it does. And in this case, it doesn't, because I don't really care. Each one just gets processed on its like completely independently. In the code that actually compiles the data flow logic, it does matter. The traversal order does matter. And so if I jump over there, I can jump over there really quick. Right. So in this, so when I compile the circuit here, this is the work list that I use. And so it goes into here. And the traversal order actually does matter. So I'm pretty sure I'm using... Oh, I'm pulling off the end in this one too. Okay. So yeah, right, because then I have to go and resort everything in order to kind of undo some of the effects of traversing in the wrong order. But anyway, like I said, I use this stuff all over the place. All right, let's get back to this piece. So I'm going to say the work list count -1. Okay, grab that item off of the work list, and we're going to do the hit test on this. So item.expression.position. Let me see how these other picks work. Did they? Yeah, that's just straight graph position. Right, because we only need the position adjustment for rendering, because this is the position inside of the graph's own coordinate system. So contains graph position. If that's true, then editor transition expression parent equals, so just going to spit out the data from here. I could be more clear about what this is. There we go. Don't know if I need to be quite so verbose about this. So we're going to go back down here and change these. In these cases, I do. In fact, I need to be more verbose. Okay. Here we go. So when this is the case, then return okay. So this is a success case. So if that doesn't happen, then we need to add all of its children. So we're going to do for each of your sub-expressions, go in here and kick them onto the work list. Now, this is dot type equals so what I want to do is I want to make sure that this is a type that is supposed to have sub-expressions, just again, in case something goes wrong. So editor, is it editor transition, special layer type? Did I not do that here? Did I do that here? Oh yes, I think I did this here with this. There we go. This is what I was looking for. Cool. There we go. So this assert just says, hey, you should really only have sub-expressions if you're an and or an or. We're not gonna, bail out, but this will help catch if I add anything else later. Like, I don't know, I can imagine, hey, only one of these things, or exactly one of these things, or 2 or 3 of these things, whatever is true. In which case, code needs to be updated in multiple places, so having this kind of assert in here is helpful. So, oh, this should actually be sub-expression though. Cool, there we go. Sub-expression. So a good practice that I should actually just demonstrate here, I should practice things correctly, is that for a struct, all the members should be read-only. This is just generally true, because unless you know what you're using a struct for a very specific purpose, which there are definitely instances where you want to do this, where you want to not have these things read-only, it helps not cause problems, because structs are always copied. They're copied everywhere. So if you pass one into a function and then change something expecting it to work like a class, where in the caller that value will get changed, you're going to have a bad time. So this is what I usually have to do. Unfortunately, you can't use the nice curly bracket declaration version when you make your members read only. Even in, I guess because it turns the code into actual just writes. It's like a shorthand, so it's not like a specially understood version of an initializer. So you actually have to just go write yourself a manual, good old-fashioned constructor, which just goes in and assigns your values for you. There you go. Cool. So now, when I do this here, all I have to do is just change these pieces. So, and one of the things I don't like about having to call a constructor is that you lose the understanding of what each parameter is, and I think it's just so much more clear when you can know what each parameter is supposed to be. And interestingly, that's actually one of the things I really like about Objective-C, because in Objective-C, if you've never seen function calls in Objective-C, they are wild. They're not so much, you kind of don't recognize them as function calls. sentences almost, where it's a labeled sentence and you essentially name each piece of the, like each parameter that you're going to call. And every time that your function is called, you have to say the name of what each parameter is. So it makes a huge pain if you're refactoring, but for code clarity and readability, it's way better than this. Yeah, I really prefer it. Their syntax is a little strange, and this is kind of getting back to the piece of I like code that reads. I like it to look nice. I'm a very particular. I don't know. We'll get into style another time, but this is not actually my style that I'm writing in here. This is I'm trying to write in the C# style. So anyway, where was I? Right. So the style of Objective-C that you're supposed to write in is not my favorite, but the fact that you can label each piece of the function as you're calling it's super great. Which I think C#7 actually allows you to do, but I haven't really seen any code written that way, and can't use C#7 with Unity as far as I know. Okay, all that for adding a constructor. So you can add the sub-expression, expression becomes the parent, and the index is j. So here's where we do our fancy little bit of recursion, or non-recursion as it is. So this adds all of the sub-expressions to that, and we're just going to keep going through this work list. Looks right to me. So go through the work list, make sure everything's actually been checked. All the sub-expressions will get pumped back into here. Then we'll go through. This work list clear should be unnecessary. It should be impossible to get out of there and do this, but hey, safety. Okay, so then if we get all the way to the end of this, that means we've gone through every transition and every node in the transition, and it's going to that just nothing was hit. So we're going to say parent is null, index in parent is -1, and return null. Cool. So now if we pick this editor transition expression down here, that's the anchor. This is for, this is for dragging. Right, they're not going to be draggable, so I don't really care about that. I'm just going to lean on the auto layout. I may allow the user to flip them left-right, just to make it a little cleaner, but hey, that'll be a toggle. And I can put that toggle in the editor transition, and that would be great. Cool, so let's see if it works. There's the old reload click. Well, I got the delete menu. Don't get it on the root. In fact, I get a bunch of null reference exceptions and assertions failed. So let's go see what's going on. This is incorrect. I do actually want to be testing expression, not sub-expression. Okay, so forget that. Because actually, I don't want to assert. It doesn't matter that I'm asserting this every single loop. I mean, I really could just put this here. If sub-expressions dot count is greater than 0. Actually, I could even just bury this in here. Say, you must have no sub-expressions, or you must be one of those types. There you go. Bam. All right, now let's go see what's happening with that null references. So as I right-click on here, null reference exception. Where are we? Did I screw something up by... mean, editor cell doesn't exist, so why would this be tested? So this is if they're all null, then do this. Oh, this is still testing parent as null. So at the root, I'm testing parent, which means that it's falling through this case, which means it's getting to the last one here, which is the editor cell doesn't exist, which is assuming that it is because it didn't get into the first state up here. Wow, I really don't like the way they put together this logic, but that's okay. It's functioning. So, this one, parent. So I want this to be the test to see if the expression exists, this to be the parent of the expression. So I should get a disabled delete menu on the root here, and then everything else I should just be able to get a delete menu. Yeah, there you go. There's that disabled delete menu. If I delete that one, hey, look at that. Look at that. Look at that. It's even putting it together properly. So that's going to evaluate interestingly. All right, can't delete that one. Delete that one. So I can change type. Let's make that the next one. And actually, I'm going to take a quick break. I will be back in, a couple minutes. And yeah, then we will put together the function that actually lets me change the type of these things and kind of start editing this tree now that I got the picker working. See y'all in a minute.
Since I was 15 years old. I was smoking with my nephew, okay? We used to smoke inside the house, we used to smoke outside the house. And we still do to this day. Well, he smokes, I don't.
All right, I'm back and ready to jump back into getting my transition expression editor working. So if this is the first time you're joining me, then I want to say my name's Carl, and I'm trying to build a little community here for people who are building games in their spare time. So the piece I'm working on today is this little editor for a state machine and data flow library. Now, this is in service of a project that like basically all my other projects. I have a number of games that I'm working on, and this would just make developing them way faster. So I'm hoping to take what I'm building here and start contributing to game jams and kind of just working on other more fun pieces. Not that this isn't fun, but it's just a little different. So actually, before I jump back into this, I wanted to see if I could switch over to one of my projects and see, I'm trying to do this live here, and see if I can show y'all something that I have built. So let's talk about, I think this one will work. This is a different version of Unity, but it should be okay. Just got to do a little re-import here. So if y'all played the game Stardew Valley, that's one of my favorite games. I have about 200 hours, more than 200 hours in it at this point, and there's just something about how peaceful the game is and how much there is to do, and just the satisfaction you get from contributing to this little world, but you get to build it out yourself. I don't know, there's just, I can sink so many hours into that game. And one of the things that I really love about it is just how friendly it is. Just the feeling that I get by being there. So let me switch to my streaming layout here. So what I decided to do was take a swing at making my own version of Stardew Valley. Oh, am I going to be able to run this? Let's see. Nope. I get some errors down here from a version of... Oh, because I have TextMesh Pro in this project as well as... I'm going to try to do a hotfix here. As well as a package. I don't know how to remove packages yet. I haven't actually done this. I think it is asset management? No. Store services? Is that where my packages are? Nope. Shoot, I really want to show you guys this. Wait, package manager UI. Alright, I gotta Google this really quick. Gotta figure out where my package manager is. Go to Window Package Manager. That's what I thought, but... Oh, I bet that it's not loading it because the package is conflicting with an internal object. So this is from an old version of Unity where I have TextMesh Pro built into the project rather than as a package. And yeah, and it's really unhappy about that. So maybe so I think that's causing it not to, right, it's causing it not to actually load the package manager UI, so I can't remove the package from my project. So let's see if I just delete this, if this works. Okay, if I get rid of that, maybe some of my text will render. Don't update stuff yet, please. Okay, can you... No, RPC is obsolete. This is fine, though. This should not cause a compile warning. Nah, it's fine. It causes an editor warning, or like it just causes compilation fail. So let's do that. You guys are seeing some real programming here where try to hotfix something. What assertion is failing here? Right, my string terminals. Okay. This might just be a hot mess. Let's see what happens. Hey, all right, well, I at least connected. So this is a little game that I put together. Oh, my text from Willie here is not rendering. It's a little game I put together that used the Stardew Valley assets. And no, I'm not going to release a game that just rips the assets, but you know, it's what I had on hand, and it's really conveys the vibe of what I'm trying to build. Where this game is all about the fishing minigame from Stardew Valley. So if you walk up, you can go fishing, and you'll kind of just chill here, and then eventually you'll catch a fish. Oh, I don't know if this is going to work. So when it wiggles like that, you're supposed to be able to click and catch a fish, but I'm not getting it. So anyway, you play a little fishing minigame, and the idea is that you catch bunches of fish, you use your bait, and then what you do is go back to Willie, and you would turn in your fish, and he would give you more bait, like you did just there, and then you'd go out and fish again. Except that the trick for this is a multiplayer game. So I need to go back and open this in an earlier version of Unity so that I can actually show it working, because right now, literally all you can do is just walk around the world, and I guess throw your fishing rod. But the way that I built this on the back end, I think, is the piece that I'm trying to tie with this explanation to why I'm working on what I'm working on right now. So let's take a quick peek under the hood, and I'll show you guys what's happening. So what I've got is this local player, and the local player is kind of the top level controller for all of the game logic. And local player has a bunch of these things underneath. It has these canvases that are for each different piece of the game that has, you know, different UI sets, all that sort of thing. And when the game starts, you can see that local player will instantiate, once I go online here, it'll instantiate a player object. So this player object is the piece that is interesting. Animator. Here we go. So because what's happening is the player, I actually use an animator to control his different states. So if you see when I move to walk, he transitions to the walking state. If I go up here to this place, then he'll fish, and he's on this fishing layer. He currently is fishing, and you can see if I go through these, he kind of transitions through these different states. So these states I'm using to explicitly control the game, how the game plays. So on each of these, there are behaviors associated with what's going on. So where's my behavior set? Oh, right. So these behaviors are being driven by these parameters, and these parameters come from here. So actually, this is the one that I should have been showing you. So what I was showing you was the animation behaviors. So, however, there's a equal or like kind of a mirrored piece on the local player, because this is networked, where when you're doing these things, it will keep control of kind of where you are and what you're doing. So here's the big one for players. So right now I'm idle, and I can be walking, and the idle state has this SMB is short for state machine behavior. I have the state machine behavior on it that says when you're in the idle state, we'll just jump over to here, do these things. And it's a set of, you know, on enter, you kind of set up some animation parameters. Then while you're updating, go through here and see what the joystick's doing, change that to, you know, hey, if you're doing an interaction, then set a trigger to start fishing or be at the merchant, or go back to idle if you're not doing anything. Similarly, so hey, if you're walking, then in here, if you're walking, do these things, you know, move the player around. Then if I go up here and I start casting my rod, you see I went to the casting minigame, and now I'm in the awaiting bite state. So the casting minigame, same thing, has its own set of update parameters. Now, I think that it's super clear and really easy to kind of create new behavior and combine pieces of code that I've already written and just be aware of what's going on in the game. There are a number of challenges with using Unity's animator this way. Number one, I don't think this is what they intended it for, and so there's a bunch of kind of gotchas that I'm trying to fix. Things like you can't transition more than one time in a frame, and you don't get it's hard to get certain callbacks about like, hey, which state are you in, or when you enter this state, do these other things as passed around within the animator itself. So if you want to take two transitions on different layers at the same time, that's just it's really hard. Or if you want to say, hey, only take, I know that all of these conditions are true, but only take one of these two transitions. Don't take both of them at the same time. So like, for instance, for some instance, if you were at a merchant who was next to the water and you were in a position where you could do both of those things, then a naively implemented controller would just open up the merchant menu and start you fishing at the same time. And coordinating that behavior in the animator that Unity provides is more difficult than it needs to be. So one of the things that I'm building in my own editor is just to make that easy. Anyway, so then the other piece that is pretty cool about this thing that I built is so in here where you're defining all your behavior, when you actually do something like, let's say set the item sprite name. I think that this is one. So this is a custom property, that's right. Let's find something that is just set locally here. So these are good examples. Let's just take position. Position is pretty straightforward. So position, you can see, is implemented as a property, and what the property does is it is probably something you haven't seen before, which just says bus.set. So there's this other tool that I wrote called Omnibus, which is available on GitHub if you want to check it out for yourself. And Omnibus is a tool that lets you propagate changes in values through the Unity graph. And it just makes it super easy to control things like, like position, for instance. So I'm trying to find where this is actually used. These are all... Okay, so here's one. So this position 2D module is part of Omnibus that says, hey, I'm going to hook myself up to a bus and grab the value from position. A bus is just it's a key value store. So from here you can see it stores vector 2s, it stores booleans, it stores, just whatever. And it looks like this. So any of these values, when I actually run the game, you can see that these things will start getting updated. So as I'm moving around, you can see that the position value is changing. And same thing, camera position is also changing. It's got this anim walking that will toggle on and off. And same thing, like which direction is forward. All that stuff on this player down here is just automatically hooked up by adding different modules. So the position 2D module says, hey, I'm grabbing from the bus over here. I'm grabbing the position value, and whenever the position value changes, I want to update my own position. So I didn't actually have to write any code to change the position of this object. I just said, hey, push this value into the bus, and then whatever's listening to it, those things can do whatever they want with that information. So that is the data flow part of Harmony, the new library that I'm writing. And that's why I'm writing this, is because it kind of puts together these two ideas that I've had. One, you explicitly drive a lot of your behavior through state machine, and two, you propagate changes in values using a graph, using data flow. So as I've become more formal about my thinking in this, what I've realized is that what this is actually doing is it's separating two kind of modes of programming. So you can have programming in the declarative style or programming in the imperative style. Declarative style programming is things like, when this is true, this should be true. When I move the position, your sprite should update its position. When I'm set the walking flag, you should run the walking animation. That's declarative. Imperative is do this, then do this, then do this next thing. Then if this is true, do this thing. Otherwise, do this other thing. That's like one step by step. That's imperative. And each piece is good for something different. So, but I haven't seen a tool that allows you to use both at the same time, at least in the way that I want. Um, usually things like StateScript, the scripting language behind Overwatch, they'll kind of mix the two together and not make either. And usually imperative will become the first class citizen, and declarative is kind of like, oh yeah, and then we have this declarative piece too. So, but I think there's some really neat stuff that you can do when you make both of them just first class and treat them both independently, but allow them to interface with each other, which is what I'm trying to do with Harmony. Okay, so let's get back to some actual development here and not just debugging the Unity update. So this is when I actually write this, so you'll see, or when I'm using this in something. Do I still have? There we go. When I'm actually using this to write a project, what you'll see is I have this joystick aspect here and fishing rod and these sort of things, because I'm actually, one of the first things I'll probably try and do is write my other project using this tool and see if I can just see how much easier it is, kind of what I run into trying to move this stuff over. But for the time being, I am going to get back to actually writing this expression editor. So right now I wanted to make the ability to change the types of these things. So let's do that. Let's add a separator here from all this stuff. So the delete is far down at the bottom, because you probably don't want to be doing that all the time. So an add item, give me content for do I need to make this a submenu? Not really. So this is going to be I can make each of these their own functions, or I could pass the type as a parameter. I think I'll probably pass the type as a parameter just to keep all that stuff in one place. But that does mean I need to make... It means that in the future, if I add more types, then I don't have to change this. I just have to change that code down here. Like, I don't have to make an entire new function. But yeah, it does mean that every time I call this, or even set this up, I have to do some more little array allocations so that I can pass all these parameters. Down to or. And we're going to do true and false. Now the first one, this is probably the most common, is going to be trigger. But we're going to have to get some input from the user as to exactly which trigger they want. Although, I could, if I have a list of triggers already known in the circuit, then I can just create a submenu here and it will say which trigger that and you can just pick the trigger from that list. So that would be better because it makes the user have to think less, and there's less, it's more exploratory of an interface rather than you got to know everything that you're doing. I think I would like to use that more, so that's what I'm going to do. Let's just set this up as a temporary thing right now, since I know that there's a next trigger So what I could do is similarly for this trigger type, I can recognize this, and then I probably need to make a little editor on the entity that says, hey, which triggers do you want to support? And then you can always just add more triggers in there if you want to. I can do that for variables and stuff too. It might be a good way of doing that, because then you can initialize all their values. Not bad. All right, I might need to do that. So, but one thing at a time. So the reason I'm going through here, and the reason I always do this, I do the full for loop rather than for each, is to keep myself in the habit of doing this, honestly, because for each is much easier and shorter to type, except that often you need a for loop because you actually need the indexed, and there's also an allocation that occurs every time you use a for each loop. And those allocations aren't big, but they kind of add up over the course of a project, and it can be just annoying to go through and remove them all. So I'd rather just write it once. Length. I don't know if this is going to end up being a list or an array, but that's fine. Add this. Disable items. So if there's nothing in here, then I'm going to add this trigger none, just so that the menu exists, because otherwise it won't have this menu at all. And then when you get your first trigger, it'll pop up for the first time and it'll just look weird, so gonna forget about that. Oh, this is kind of neat. So I can keep using the same one, just pass an extra parameter in the array if we actually have a trigger. So triggers I. This does mean then that triggers need to not have slashes in them, otherwise this is going to get a little messed up. Probably not necessary, slightly safer. All right, so let's actually go add this little piece. So we're going to set the expression type. This is going to be expression. What is it? It's the expression type in trigger. Basically just repeating the exact same pattern from down here. Now it may not have the second element, so because it's only going to have that if the type is trigger. Oh yeah, you can't use as for this because it's a value type. Actually, just have to do a direct cast. So we're going to say right. First thing we can do is on the expression if we are becoming a non-array type, then we want to clear the sub-expressions. Otherwise, we don't want to clear them. I would really love a macro to just take these and make them into case statements. It's actually really easy to do, but I just haven't bothered yet. Whoops, went too far. Let's do that. because I'm going to need to do this a few times. A little hasty with my copy here. Safety first. Got to make sure that if something goes wrong, that you just tell somebody about it. So if we are becoming a okay, this is what I need to copy actually. We're becoming a non-array type. Another way to do this would be to use attributes, like C# attributes on each of these. And what I could do is just say, hey, go look at the type here that you are, check its attributes in the declaration and say, if it's an array type, then it's an array, otherwise it's not. Man, that's a better way to do it. That's such a better way to do it. Because I would clean up a bunch of other places too, where I'm doing those manual checks. Oh, do I want to do that right now? Yeah, what the heck? Sure, I'll do that right now. So let's find out where else I declare attributes. Yeah, that's all over there. Okay, so I do use these, I do use these in other places too. It's not like a huge pain, but... Alright. This is... I feel like declaration order doesn't matter, so I'm just going to declare this here. This is a attribute usage... I'm not using system in this? I guess not. Okay. So we say attribute usage, attribute targets dot, is attribute targets enum going to be what I want? I mean, I can just try it, but, oh, I don't want to navigate to attribute targets enum. Do a little research here. So attribute targets should use our enum members. Perfect. Oh, there isn't one specifically for enum constants. Oh, interesting. Okay, so target field will allow you to query attributes C# on enum constant. Type.getMember. Holy cow. Okay. Well, I mean, this is going to work. It's a little funky, but okay, so we need it to be declared on field. And this is going to be has sub-expressions attribute. So I'm just going to declare this for this has sub-expressions. For all parameter type, right? Don't have any. So I don't even need that. Great, cool. So those are the only two that actually have sub-expressions. I'm just going to write the code in here to actually do the check so that it's nicely contained and I can call it from wherever I need to. I'm just going to grab whatever this guy wrote here. Static bool. dot has subexpressions attribute found on so that's the value. Get member. So we get the member as a string. And then we say we're just going to assume that this works. Get custom attributes. Okay, so there's no has custom attributes. Yeah, so just have to get that array. Okay, so if it's found on that, then say if it has subexpressions attribute. It's pretty cool. Is found on that type. If it's not, then clear it. Okay. So the other place I need to fix this is debug assert. This one, which is, so we want to say this, that there are no subexpressions, or the has subexpressions attribute is found on whichever type that it is. Cool. And then we need to do this in one more place, which is the Harmony editor utility, which is right here. So, in fact, I'm just going to copy this exactly. Take this, stick this here, and hey, just right after I talked about the for each allocating stuff. It's all right. Expression type, cool. Away we go. Man, that's unsatisfying. You know what, I'm not gonna fix it right now. Okay, so this has subexpressions attribute now allows me handle this much more easily since there's no exceptional case. So if this just handles the case if we're moving from something that does have subexpressions to something that doesn't, clears out its subexpressions. The expression type is just going to be the new type. However, if the new type is true, doesn't matter. If the new type is trigger specifically, the other ones I don't care about. Because triggers should be the only one that actually has a trigger. Then expression.trigger, I'm gonna clear that out. And we're not gonna set it to null because I feel like that's gonna have, you know what, I'm gonna set it to null. It's gonna have other implications. It made null reference somewhere, but it should be handling that case anyway. And in the case of Unity, so when you're using the Unity serializer, if you set a string to null, Unity is going to barf at you and just set it to not null empty string because it really doesn't like serializing null. So, and I don't know why they made that decision, by the way. It baffles me every time that you can't store null values as properties. But in any case, or as string properties rather. So I'm not using the Unity serializer, so it doesn't matter. I can store null values. And in this case, we do want the trigger to be something. In fact, we know exactly what we want it to be. We want it to be the third parameter of expert type trigger array. There we go. So Pop back over here. And I think, where the rest of my tree go? Concerning. Wait. Reference not set to an instance of an object. Maybe this is an older version? Let's see what's happening here. I'm going to delete this transition, start over, see what happens. Okay, got that, got my true. Let's change this type to and. Cool. Set it the trigger to next. Yeah, look at that. So we're saying it has to be next and true. Or I can just say that this one has to be next. That looks pretty good. So now I need a little section down here that actually adds a child. Yep, cool. So after the separator, I'm going to put one that if the editor transition expression type, do this thing again, has sub expressions dot is found on. So now we're going to be able to actually add children into this array or into this tree. Otherwise, we're going to add the disabled version. Child sub-expression. Child's the usual term. Add sub-expression. And we're going to call it with the parameter there. Editor transition expression. I don't need the array. Go into here and write this little function. This one is just the transition expression. Right at the end of this. There we go. Okay, take this one as a transition expression, and then in here, I can do that assert again because reasons. And safety. Can't tell you how many times adding all these assertions and checks everywhere have just prevented little annoying bugs. And I honestly wish I had more of them in here right now, because as you can see when well, this is not going to compile, but when I'm going around through here, you can see how it jumps every once in a while. I'm pretty sure I know where that's coming from, but if I had a couple more debug statements, it would just tell me rather than me having to do this and just kind of work around it for now until I go fix that, which will probably be something I do pretty soon because that's really starting to get on my nerves. Anyway, back to sub-expressions. Let's add a new editor transition expression. Let's see where else I do this so I can just take some template code. Bam. Like 5 lines down. True, and sub-expressions is just a new list. I think, does it default to that? Yeah, it does. So I just don't need to do anything and just say that it's true, and away we go. That's why when I was adding these things, it wasn't writing afterward. Okay, so yeah, that's good. I can't delete it because it's the root, and I can change its type, which that works. I can change it to be an and then I can add a child. I can add another child. I can make this one into a trigger. I can make this one into an or statement. And I can add a child to it. That is pretty cool. I'm not gonna lie, I'm pretty proud of this. Awesome. Okay, well, so I can at least build that piece. I mean, these things don't look the best, but now I have this next trigger as the expression in here. And when I save this, and it actually writes out the asset, well, let's see what it's writing. Let's see if this is actually going to reference the trigger. So, hey, triggers, content, next. That's good. That means that it recognizes the fact that that trigger exists. Now, in transitions, where are my transitions? Cells, layers, here we are. In the first layer, has a couple of states. The transition, this is the entry transition. This one uses trigger 0. So it pushes 0. Now is that how that's supposed to compile? So push, right, it's supposed to, so the way that I created this is gonna be fun to work with here. So I'm gonna say, I'm gonna do an and we're gonna do one and, add child. This one is gonna be the next trigger. And we're gonna read the logic of this to see what it did. I'm stoked to see if this works. Okay, so it's a stack-based expression evaluation language where it will go from the, let's actually look at the code because I don't remember which direction it goes. I think it goes from the bottom to the top. This is in, where's my code? I haven't looked at the piece that runs this in a little while. Entity. Okay, no, these are the program definitions. Okay, so here we go. So here's the transitions. So for each transition, yep, they're doing the sentinel again. Because the sentinel is allowing me to run multiple this loop allows me to run multiple transitions in the same frame, but in case there's a loop of transitions, it's going to kick you out at some point and say, no, stop it. So here it's running through every transition, and it's checking to see the ones that are coming from the current state, goes in, and there's this stack that it's going to create. So the stack will start with this expression. It starts from 0, and then it runs through the list. So, and then what it should be left with at the end is a value of either true or false on the stack, and that's it. Now, at this point, actually, I should also do a little extra debugger there. So what it's going to do is it's going to push the value of 0, of trigger 0, which in triggers, trigger 0 is next. So it's going to, this is going to work. It's going to run the piece of code here that says, hey, push, go find the trigger value for 0, and then go in and also add the value of true. So now there's two things on the stack. There's whatever the trigger value was and true, and then it's going to apply the AND operation, which will pop 2 of those off and push the result, which is exactly what this describes. It says, hey, go get trigger value, add true, and then AND them together. So what I created is a way of flattening this expression tree down to just an array of evaluations here. So I think this will work. Now the question is, can triggers actually be set? Let's find out if I wrote that code yet. Well, triggers can definitely be disabled. Get set trigger by name, which is referenced in here, so this will definitely set that trigger. Ooh, okay, fingers crossed. Let's see what happens when I run this. So, if all goes well, what should happen is it should, I'm going to set this for 2 seconds, should rise for 2 seconds, and then jump over to the right, and then go to the right for 2 seconds. Let's see if that's what happens. I'm pretty nervous about this, actually. Hey, look at that. That means it transitions states correctly. Nice. Now, man, transition. Okay, so transition after delay. That works correctly. So now I can do something that's a little crazier. I'm going to add another transition after delay to this state and say the trigger is going to be, so it's again 1 second, the trigger is going to be last. These are going to draw on top of each other, but I'm going to do this anyway. Put that here. This one goes the opposite direction, and the trigger is, ooh, how do I, oh, right, that menu is hard-coded. I must have a list of these somewhere because it's definitely compiling them. So I should just be able to find my set of triggers and then display that in the list here. So this transition that's going the other way is going to be the last trigger. So now what it should do is it should flip-flop between them, and basically it'll do this weird up pattern to the right. Just jump. And it's correctly, my state machine's working. Look at that. Oh, I'm very pleased. That's awesome. That's so cool. I know it doesn't look like much, but it's taken me probably 20 hours at least to get to this point where I've learned to, you know, draw this custom editor and like all the little pieces, get all the stuff to render, get references to Unity objects, serializing properly, learn how to select like different objects in here, move them around on a grid. As you can see, just make this little expression editor that you guys watched me build it over the last 3 hours or so. And that's just great. That is just great. All right, well, now I gotta figure out what I'm gonna do next. I'm gonna take a quick break and be right back. Hey everyone, if you're just joining me, I'm Carl and I have declared victory in the case of expression tree editing. I am working on this little editor for the game that I'm building and just wrapped up some work to make it so that I can edit these little expressions dynamically using this context menu here, and then they compile down and actually function. So super happy about that, but still got a lot of work to do in cleaning things up and kind of getting this to a state that is a little more functional. So one of the things that I just hacked in order to get this working was this set of triggers here is hard coded, and I need to make that dynamic. Also, there's a couple other things that I wanted to kind of tackle here. I want to get this list of transitions dynamically. I'd like to add a set variable in time to time and state to these this state here, so that I can basically write a little new script to attach to this thing that will make it so that the object doesn't jump around when it's transitioning between these two states. Uh, Also, speaking of, you can't tell that there's two transitions here just because of how it's being drawn. So I think what Unity does, it like separates them out a little bit. So depending on, I guess whichever direction it's going in, it'll offset it from the center. So I'm gonna do the same trick there. And what else am I gonna do? Yeah, we'll put little arrows in the transitions, that way I know which way they're going. Clean up this expression rendering thing a little bit so that they're not just these weird buttons that kind of overlap with this weird circle at the end of it. Like, that can just be way better. And then finally, I want to fix the jumpiness that occurs like that when you're dragging this window around, because it's finally got to the point where that's just got to go. That's got to be fixed. So yeah, got a bunch of work ahead of me here, but going to settle in on the first thing, which is figuring out where these triggers are coming from. So I know I can just type these trigger names into any of the states. So like transition after delay, let's see how that's implemented. Transition after delay just has a string that is a trigger. So how do I know what the triggers are? Because obviously in the JSON that you saw earlier, it has this little list here of, hey, guess what? There's this trigger called next, and I know that it's in there. So how does it know? Where did that come from? Well, it's got to be written. So where do we get the trigger names? So here, transition triggers. Oh, interesting. It's actually the other way around. It's the transitions, it's these things that define what the triggers are, and then the states just reference them. So, hello, can I put you down? Okay, thank you. Gotta fix that stuff. So this is going to be a little bit challenging, because what I wanted to do is have this little menu here where, hey, it's, trigger, and then I just pick which trigger it is. There's two ways that I could go about implementing this now okay, so for a context menu, if you can't type in a context menu. So I could implement a context menu myself that you could type in, which that's gonna be a pain. Could do that. I want to do that at some point because I want to be able to drag and create. If you've ever seen how Unreal's blueprint system works, I think it's just super clever. If you pull values out, then it will, like, so this output value, for instance, if this were the Unreal editor, I would pull this output value to here, lift up, and then it would give me a little menu saying, hey, which blocks do you want to create? All of these blocks take the value that you're dragging as an input, and then you can, just like type through a filterable list, and it will pick the ones you want. It makes it super easy to create things. So I definitely want to do that at some point. Now, I could use that if I built a solution that allowed me to do that. I could use that for triggers here, where if you click trigger, then it would allow me to, pop up a little menu, type in it, and say what I want the trigger to be, and then the trigger would exist. That might be the right thing to do, actually, because if I did that, number one, I could reuse the code for the next piece, and number two, it would allow me to keep all of the data inside of this editor, because another option for implementing this, I could go to over here, and where I'm on the outside of the editor, and on the object itself, I could add, hey, these are the sets of triggers that this object has as properties. Now, I could do both. I could have it stored as properties and then also used within, and also make that editor, which, come to think of it, that might be the way to go, because one of the things that I'm anticipating being able to do is set triggers on objects that are not yourself, and that would be a handy thing to be able to query. Now, the trick with being able to set triggers on things that aren't yourself is matching the names, so which means it would need to be a string input. But if they're properties of the entity itself, I could have it, when it loads, go through every entity in the entire project and say, hey, this is your list of potential triggers. Like, just use anything from these set of names. There you go. There's another option. I guess option number 3, I could have a defined set of trigger names that just exist for your project. You can use any of them, and you can use them in any way you want to, but they have to come from that list. The benefit of doing that is I can make that an enum. And I can make that code, which means that you can do all sorts of validation on it. And I think that might just be what I want to do, because that's way easier. It all gets defined in one place. I'm expecting people to edit this code anyway, because, well, I'm writing this for me. Then it solves my problem entirely, because I can make a little drop-down menu for these things, and like this little pop-up menu I can automatically populate. It doesn't give me the nice piece where I can do that little auto type thing that I really want to do. But for the meantime, I think that's fine. So what if I just did that? What is the downside here? Saving and loading need to be done not by index, they need to be done by string name, which is how full serializer works anyway, so that's fine. It would mean compatibility between versions is... No, I could still maintain compatibility. What I'm thinking is, if I have... because everything gets compiled together. So the way that it works right now, these triggers are just strings. And so it builds a little map saying, hey, this string is this index. And this actually simplifies my code somewhat significantly. So I build this little name to layer index, name to trigger index, where I'd go through and I coalesce all the triggers into a big list, and then I stick that list into the data file, and then just away you go from there. This does mean that whenever... okay, so here's the trick. Whenever I set a trigger, so set trigger by name, for instance, wouldn't take a name, it would take the trigger enum. And that's fine. Now, this array is an array of all trigger values. Now, depending on how many triggers your project has, this array could be very, very large. It could be thousands of triggers, which means that even if your little state machine only uses like 5 of the 1,000 triggers, then it would still have an array of 1,000 triggers that it would set booleans in. Now, indexing an array is really not a big deal. Booleans are stored as bytes, so I mean you're wasting a lot of space, but I could always store them as bits if we needed to, which means the cache line operation. So I could make a bunch of stuff fit, like more triggers I'm ever going to need. And this does give me so many other benefits, but this also means that I'm going to do something that is that hurts a little bit, which is I wrote a bunch of code to get this trigger stuff to work using strings, and now I get to just delete it. So let's do this, I guess. Come on. So all of these other pieces have been derived from something, I think. I don't think I've done any others. There's a version of this that I swear I did something similar to this, but everything else here is derived, where it's this read float setting is a cell, or these other things are aspects. Aspects, by the way, are basically shortcuts to sets of behavior that a particular, I'm calling them entities right now, but I'm going to rename them, that a particular entity will have, so that the cells within can rely on having an aspect on the entity and saying, hey, I work on something that has a transform aspect. So if you have a transform, you can use me on this, you can use my functionality on this thing. Not sure how far I'm going to go with that right now, because there's also this idea of direct references, which works pretty well. That's kind of more Unity-ish, but I implemented it, so it's still in there. Anyway, as I was saying, all these different pieces are derived, whereas I'm about to build something that is just integrated. And I'm pretty sure you can't do a partial enum. Let's see if I can declare a partial enum. Nope. Sorry, foobar. You can't be partial. Which means that this is exactly what I have to do. I have to rely on the fact that that the client of this project has declared their trigger types, and I have to make namespace assumptions about it, or I have to query it. But I mean, if you're using Harmony, you should be using Harmony, so that I feel like this is just fine. So let's declare trigger type. Something feels weird about this, but I'm doing it. Okay. Setting trigger now takes just the trigger parameter and this piece that has to be last. So there's this, what's going through my head right now, there's this kind of programming that I feel like is something a lot of people avoid, and it violates almost a purity rule, or like an unspoken thing about programming that is a little hard to describe, but it's the feeling that your code should be self-contained, that your project, your program, whatever you're writing in, should be fully understanding, fully encompassing of its own functionality. And this can lead to some weird situations. So an example of this is reflection. So the reason reflection is necessary is because a program needs to understand itself. Now, you can write programs in a different way, which is how we used to do like row procedure calls, and some libraries, Unreal still just works this way, where you have a precompile step, which doesn't so much create like dynamic reflection as it does, it just builds code for you that then the second layer of code just runs. This seems unsatisfying for a lot of people, and I've definitely felt this when I was creating this library called Direct Craft. It basically did object serialization for the game that I was building in college, and I went out of my way to be able to implement a form of reflection in C++ entirely in C++. There was no precompile step, there's no static code analysis, there was none of this other, stuff that makes that way easier to do. I essentially I've spent like a month or two hacking on how to do between templates and static members of templated classes and some macros, be able to set up my static constructors. That was the big thing. Static constructors on static fields of templated classes. Being able to set all that stuff up in order to do reflection inside of C++ and without relying on anything external to the program. So the reason I bring this up is because what I'm doing here feels like I'm violating some unspoken rule about how programs should be self-contained or libraries should be self-contained, so I'm writing Harmony, which is, driving all this logic and everything, but it's got this one little piece that's like sticking out the side that is, hey, but also there's this trigger enum that the client has control over. You guys get to do whatever you want with this trigger enum, and by the way, it's got to exist, it's got to have these parameters, it's got to work this way. But you have to declare it because we can't declare it for you. And it's more satisfying if that were a part of this program, if this were a part of Harmony that you kind of poked at. But it's often the case that doing something that violates this rule is just faster and more effective than trying to do something that is pure. So another example of this is using the file system as a object hierarchy. So it feels really dirty to do what a lot of Android projects do, which is, just Android applications are built this way, and iOS too. Which, if you haven't poked around at them, they're just zip files. Like what it labels as an application is it's an icon on a zip file, and the whole application is stored within this zipped up file. Now, it works great. Like, it makes it really easy to understand how this application is built. It's not like a Win32 binaries used to be, where they're like all packed in different layers and there's this inherent structure in a single file and whatever. It does end up being a single file, but you can do the same thing with an entire object tree. So imagine in Unity, like this object tree is being built here on the left was literally represented as files on disk rather than being saved into one single scene file. And maybe this is the way it works internally. I don't think so, because I'm pretty sure they use YAML inside of there. But for the sake of argument, let's say that they don't do this. So if we were instead to make these files on disk and represent each one of these objects with its own file, and then objects that contain other objects with folders, then we could just say a scene is a zip file of all of those things. And it's actually super simple then to write editors for this, including external editors, because you just, hey, unzip this file, and then everything's right there. It's all just plain text. But there's something, again, there's this kind of rule that we have as programmers, which is unspoken. That is, yeah, but you don't do that. Like, if you have a data format, if you have data, you should use the right format for that data. Don't just spit it out as text and save it to disk and abuse the file system as the thing that's creating your structure. You should structure your data yourself. And I don't think it's such a bad thing. But for some reason, we're all taught that way. Or at least we see other people write code that way, and then we just kind of emulate it. And so I guess the point that I'm getting to is I'm okay with this. Even though it feels weird, I'm okay with this. All right, so we have... Yeah, I'm gonna have to edit stuff all over the place here. So we're just gonna go through a bunch of places. So this is, okay, set that trigger to true, which that'll be fine. Triggers in here. This is when we're actually initializing the circuit. Yeah, that's right. So this deserialized triggers is no longer going to be a thing. We're going to say well, if it doesn't have any scripts, then you still have to have triggers, sorry, in this case. And again, like you just have to rely on this. I could use reflection to get it, but then that's actually ends up being a constant. Using the reflection method ends up being a function call with a bunch of inspection, and it's way slower. But it just rely on this variable existing, because if it doesn't exist, guess what? This program doesn't work. Trigger names is not a thing anymore. Zero references. Oh yeah, trigger names, they're not a thing. Okay, there we go, there we go. Let's reset all the triggers, that's fine. Transition triggers. So in this case, this actually just gets to be a trigger. We have to cast that there. So the other place this is edited is here. So transition triggers. This is going to have to be list of trigger. So we don't add trigger index because we don't have to have an index now because we know exactly what it is because it's going to be of type trigger. Then we go to update all these ones. Oh, good. Well, I'm glad that has no references because... Oh no, hold on. Right. I think that this should be called set type. I don't need another one here, which is the invalid trigger. Which I'm going to place after count. Which I'm pretty sure doesn't screw up count. This is the only one that matters because it's the only one we call. Yeah, we don't need the other ones. And even in this case, we don't even need this one because it's so simple. I think I was expecting to use these more. So let's just... Ah, right, okay. Oh, this is the debug function anyway. So, don't even care. So this is if I right-click the anchor, which maybe there's something else I want to do there, but whatever. Oh, right-clicking the anchor, I can make it flip sides. Okay, so I did that. Don't need to get that anymore. The references here need to be updated because this needs to be trigger toString. This is correct. Okay, and so in the function that calls this, we need to make sure to actually pass the correct type, which it is not right now, because triggers is this array. So now we can use system, well, I think I've been using system already. Let's get values, type of trigger. Check this out. And this makes this way simpler. Can apply to get value I. Hey Warner. Sorry if you've been on for a little bit. I've kind of been focusing on this. So I'm working on a library here that allows me to do dynamic editing of it's a visual program editor. And so if I show you this piece over here, so up top we have a little state machine that drives some logic, and then down below we have the path from the variables that the stuff up top sets and maps it into some behavior in the game. So let me wrap up this trigger work here, and I'll show you what it does. So basically I'm working on, so the purpose of the library is to make it so that I can write code for game jams faster, because a lot of the programming that goes into game jams is plumbing. It's like, if this value changes, move this thing around the world. If this, I want to pump out some colors from in this state, then change the color of this object or set this piece of text. And this kind of handles all of that stuff for you, so you can just get down to the part where you write the game. All right, so triggers I. This is just the value. Convert to type string. Oh, right, it's just not saved. Okay. So this one is supposed to be last. This one's next. Okay, so that should have fixed that. All right, so let me do a quick peek at the new set of triggers here. Oh, when it saves, I need to make sure that this is not still being set. Okay. Name to trigger index should have no references. Yep, and then the same thing, triggers also should have no references. Yep, except for this one, which I'm going to delete. Okay. So turn that over and open this thing back up. Let's go check out the entity asset and see what kind of JSON this thing spit out. All right. Why do we still have triggers? We shouldn't have triggers. Oh, I bet I need to cause it to save. That's why. There we go. Okay, good. No more triggers. And the trigger that I have here is just by name, which is correct. No trigger here, trigger next, trigger last. Just push that one, push true and. Okay, good. So all of this work to make this cube move a little bit. But it goes up, and now it's going to go over, and then it's going to go back up again, hopefully. We go back over. Well, it was supposed to go back over. I guess the transition back doesn't work anymore. Maybe I need to recreate that just to see. All right, which one am I going to delete here? Top one, of course. Oh, I set the trigger. That's just wrong. Okay, so you create the transition this way. This one is going to be on next. Create the transition back, and this one is going to be on last. I need to remove these things from here, obviously. So now, if I do this, now it should go up, and then it should transition to the overstate, and then back up, and then it should transition to the overstate. Perfect. Okay, so now the state machine works. So I can just build, basically what I'm doing is I'm making it so that I can build programs visually, and but with a lot more flexibility than, say, Playmaker or Unreal's blueprint system, that sort of thing, because I'm combining two different systems together. One of them is this state machine up top that allows me to attach scripts to every state, and the other one is a data flow down bottom that takes changes in values and maps them to behavior. So I'm actually going to see, so the reason that the cube jumps right now is because it's using the overall clock to, like, the time in application to set the clock value and second clock value. So I'm going to write a new script, and we're just going to jump in here and see if I can make the cube smoothly move up and to the right in a little stair-step pattern. So what I'm going to do is, in testing here, I'm going to show you guys how easy it is to add this stuff. So set variable to time, and I'm going to make a new one of these that is, instead of set variable to time, is set variable to time in state. I'm going to say private float timer. Done. So yes, so I need to, these states persist, so I need to reset this every time I enter. But then I'm just gonna do timer. Because of float accumulation error, we're gonna do it this way. Equals time, and then time minus entry time. Okay, so now I have the set variable to time and state, and as soon as this reloads its script, bam, I'm gonna go, and in this thing, I'm gonna say I'm gonna remove the set variable to time parameter there and add a set variable to time and state. Now I'm gonna set the x variable based on time in this state, remove set variable time from here, add time and state, set this to the y. Now down here, this is going to be x, this is going to be y. So now when I run this, it should move 2 units to the right, 1 unit up, and then 2 units to the, oh, it went back to 0. Right, because it's not accumulating. So it's resetting on each axis each time. So that works, but you know, it's not the behavior that I wanted. So let's make another one that says add time to variable. So all this is going to do is this is going to say entity.read variable plus time.smooth delta time. And when I read this value, I forget if I specialized this already. No, I haven't. I've only done it for registers. Right. So we're going to read this, cast it to a float, and then do that. Now, if the variable doesn't exist, let's see. Oh, I have specialized it. It just does it this way. So entity read variable, value, float value equals 0. There you go. Okay, so now it's going to accumulate the, it's just going to add the delta time. Delta time to variable? Yeah. They're going to do this for those variables instead.
See, when the odd so-called, they came to me and said, dirty, wake up, yo, man. I said, well, come on in. So they're not dead.
That's X, that's Y. And now when I hook this up, now it should just accumulate over time. There we go. Now you have this nice, smooth little behavior that, I mean, you saw how long it took me to add that, like 5 seconds. Not actually, more like 30 seconds, but still, is super trivial for me to go from, I wrote something here that just reads and writes the value on a variable, to adding it into my state machine, to getting it to drive the position of an object. And you could tell me, oh yeah, well, you know, Unity would let you, if you were just writing this as a mono behavior, you could just attach this directly to your object and have it run that way. Yes, that's true. But what that doesn't let you do, what is more difficult to do in Unity and requires more code, is all of these hookup pieces. So for instance, if I said, oh, well, this X value, I actually want it to, you know, drive Z instead, that's all it takes here. And that's pretty clear that that's what it's doing now. It's going backward instead of going to the side. And this kind of clarity, I think, is just so helpful when you're doing a game jam. It makes it really easy to reason about what's going on in your program, and honestly just not worry about any of the details of how this stuff is getting done. You just want it to be done, and this lets you do it. So, man, there's so many things that I want to do next. I'm excited that all this stuff is starting to work. So let's see, I've got the transitions, so we've got the triggers dynamically now. Did a little set variable to time and state. I also added the add delta time to variable, so that my little cube moves normally. And I think I need to fix a couple of those little jumpiness things, like some quality of life stuff. So the first thing I'm going to do, because it's just really bothering me, is fix that jumpiness. So I'm gonna check in really quick here. These triggers as an enum. I was using triggers as strings based on what Unity had done, and because in the animator they have all of their parameters to the animator are strings, which then get hashed, and then they use the hashes internally for actually manipulating those values. But since I'm living in a world where I have control over the user's code, or how the user is going to be doing this, because also the user is me, I can just say, you have to stick all your triggers into this trigger enum, and then away you go. That worked out really nicely. Still super happy with that. Oh, I should also clean this up. So count an invalid. Let's just do that. That's super quick. Context menu for, so if I is, these should be in order, but just in case. Okay, so that'll make those things go away in here to make this less distracting. If the trigger is next or last, then great. Okay, cool. So that works. The next piece is that jump. So let's find out why I'm getting a jump there. I need to add some more debugging stuff to this. So scroll. I think is what I'm calling this. So, right, if I can look at that little, there's a little label down here at the bottom that shows me exactly what's going on. So I'm going to close my editor, open it back up, starting at 0. I forget which gets edited, scroll position or scroll anchor. I think scroll position gets edited. Scroll anchor is the top left, most top left point on the screen that you've seen. That is the scroll wheel. Scroll position on mouse down. I think this bug, so I used to have this thing working very nicely actually, and I think that the bug got introduced when I started adding transition drags because I needed to be able to create transitions from a context menu, whereas before I was already inside of this loop dragging out the output. So here I'm already inside of the on GUI, and so it's really easy to just set all my state from there. Whereas here, where I say create transition, I need to set some state about what's going on in the app from, or what's going on in the inspector from a context menu, and which can occur at any time. And I think that when I did this is when stuff started getting messed up. Okay, so 0, 0, this is the position anchor window size. So I mouse down, nothing changes. Mouse over, mouse up, position 0, 0, and now we have that new place. Mouse down, dragging. Why are we not jumping? Okay, we jumped there. So this is the last place I mouse down. Now if I go here, now I'm jumping. So here, I jumped again. So does scroll position on mouse down? Maybe mouse down position is not getting set properly. Where does mouse down position get referenced? Let's put in the context menu. I feel like mouse down position and mouse graph position are going to be important in debugging this, so I'm going to throw them into this little window at the end. Okay, I'm going to close this again and see if I can reproduce just from scratch. Okay. So this is updating my graph position, which is fine. Now, mouse down position has been set, scroll position is 0. Okay, so we're all good here. So scroll up. Okay, nothing happens. And if I mouse over here, Oh, that's interesting. The mouse down position and the graph position are different. So if this is correct, it's going to jump down and to the right? Okay. So now they're the same. Whereas, so if I click way down here, they're offset by a fixed amount. Wonder if I can screenshot this really quick. There we go. All right, let's go see what's going on here. Okay. Oh, really? Come on. So these are the values we need. So let's bring up an old calculator here. Say 1314 minus 1182. So often these values will be something important or something they'll reveal something about what the bug is. Well, in this case, so that's 132 offset on the X, 731 minus 643 is 88. Is that, by any chance, this amount? See, the scroll position must be getting added to, so mouse down and the graph position. The mouse down position is getting set to the scroll position plus the graph position on the mouse down after you've dragged for the first time. So scroll position on mouse down position. Let's see if the graph position changes immediately after mousing. So mouse down to graph position. Okay, in this case nothing happened. But if I go over here, that's the graph position, 519, 184. The mouse down. So the scroll position is still the thing that's screwing it up. Now, does that mean scroll position on mouse down minus scroll position on mouse down minus scroll anchor? It's using the scroll position that's one step out of date, because if the scroll position on mouse down has not yet been updated, okay, why am I using scroll position on mouse down? Is it because the scroll position... Oh, it's because, okay, so the scroll position on mouse down is the thing that allows me to update the scroll position from there. But the mouse graph position depends on scroll position on mouse down. So that just doesn't work, right? Let's see what happens if I just make the scroll position. I remember doing this for a reason, but let's just see what breaks. That, you guys can't see that. That's not quite That's not quite right. And it's because I'm using the scroll position, which is changing while I'm dragging the mouse. So we do need scroll position on mouse down. However, the scroll position on mouse down needs to be updated on mouse down. So we do that, and then we say mouse, shoot, but I'm in the middle of this thing, which means the mouse graph position. Okay, so the challenge here is that the reason I get the mouse graph position way up here is because as soon as you start adding context to your current state, the event current mouse position value changes because it starts returning it to you in your current frame of reference, which kind of screws things up. So I mean, what I really need to do is I need to update scroll position on mouse down here, and then I need to update the mouse graph position here. And cross my fingers, basically. And jumping? No jumping. All right, so immediately after I've done this, then I should be able to click these things, right-click this. The state works properly. Why can't I let go of you? Hello? I would like to stop, please. Oh, interesting. If I click on it, yeah, if I click on it, it lets me drag with the mouse up. But it doesn't always want to put it back down. Okay. Allow drag with mouse up if you let up within a short distance. Okay. So then you need to, I bet what's happening is, so it allows the drag of the mouse up, and then the second time, now it's like, what is it doing? It's saying the second time I click, oh, if I put it back where it was, maybe? I'm going to turn that off for now. Just say no dragging with the mouse up. You have to click and drag mouse down. And that's it. Yep. Cool. That rule, I think, just makes it feel better. You don't get something accidentally stuck to your cursor and you're worried about it. So I'm just going to comment that out and say this doesn't work all that well. Okay, so we fixed the jumpy problem, which is nice. We fixed the dragging things getting stuck to your cursor problem. Let's see what the next one is. Right, I want to move the transitions apart slightly so that this bidirectional transition doesn't look like just one transition. So where I'm drawing my transitions, and I created this fancy get editor transition points at one point, and this is going to help me out a lot because right now I'm going center to center. And what I should be able to do is say from the center, cast that into a vector 3, which means it has a z of 0. So vector 3 dot cross to center minus from the center by, hold on, it should be z cross that. So vector 3 dot, whoop, hello, vector 3 dot forward. So the cross product uses the right hand rule, which is you stick your fingers, so if you have the 3 axes, so let's see if I can do this, the x, y, and z, then whichever axis you're coming from in the cross product, you put your fingers up that direction, and then whichever vector you're crossing to, you curl your fingers in that direction, and the direction of your thumb is the direction that the cross product will be in. So what I'm doing here is I'm saying I'm taking the vector 3 in the z direction and crossing it with the direction that the vector is going. So the transition line is going. So 2 minus from. Is that correct? Yes, 2 minus from. And then I'm getting a 90-degree angle vector back from that. So, because what I'm going to do is I'm going to displace it by a small amount in that direction to separate these 2 lines from each other. So I'm going to normalize that, multiply it by a magic number, because let's just do that for right now, and say from equals from the center plus bump times 5 normalized, and it should have no z component. Dot to vector 2. Actually, so I can do it this way and save a bit of the normalization. Okay, this should bump those lines apart. Ha ha ha, look at that. Isn't that cool? That's pretty cool. So, however, I'm pretty sure I call this middle. Yeah, that's not doing the right thing. So I need to do draw a line from, this is drawing those points, so from 2. I bumped them in the opposite way that I thought I would bump them. So I want I want the 2 to be on top. I don't know why, it just seems right. So instead of doing this, I'm going to do the negative cross product, which is backward. Oh, is it back instead of forward? Sure is. Okay, let's go over here, bump those lines apart. There we go. Check that out. So now I have transitions that are a little bit clearer. Now, the cool thing is, if I create another transition going backward, they'll double up, but because I have now 2 trees, it makes it obvious that there's 2 of them. The slightly less cool thing is that I can't select one and not the other. So I should probably do something about that. I mean, really, with expression trees, you don't need to have multiple transitions, but it's fine. I'll support it anyway, because it's possible. Sorry, you do need to have multiple transitions. You just don't need to have multiple transitions between the same 2 states, because the expression tree can support that. Whereas this is one of the things that you just can't do, for instance, in Unity's animator. You can't have multiple expressions put together in a logic tree. You have to put them, there's only 2 things you can do. You can do every single condition has to be true, and multiple sets of transitions that are lying on top of each other. That's it. That's all you got. So here I'm gonna do, this is last. This is going backward. All right, but I want some arrows. That's the next piece I want. So let's figure out how to draw an arrow. I think there's got to be a handles thing for this, right? Let's see. Get editor transition points. This is going to be called at the point where I want to write this code, where I'm drawing transitions. Handles. I wonder if an arrow cap is what I want. Like those used by the move tool. I mean, maybe. Let's find out. Let's just see what drawing a arrow handle cap looks like. Looks like nothing. Okay. Draw cap function. No, that's the type. Lines, draw polyline, draw rectangle.
Can I stay a bit longer?
Stay forever.
I mean, I could just draw a polyline, which that would work. But you think that there's going to be a better way to do this? Hold on. Maybe this is it. Oh, this is another one of those cap things. All right. I mean, sure. So then we got the control ID. Its position is in the middle. Give it a rotation and then a size. One might be, you know, maybe one is just like so small we can't see it. Nope. Draw arrow. We don't need the event type. Oh, are you getting replaced? Arrow cap. And why are we upset now? Okay. So it just took me on a little journey there back to what it is supposed to be now, but it is not working. To the Google. Let's see what's going on. I'm gonna go and say draw arrow Unity editor. Draw AA convex polygon. I mean, if it comes down to it, that's what I do. Yeah, because these arrows are kind of heavyweight. When I draw this edge, what does it use? It uses handles, draw Bezier. And does draw Bezier take 2D positions or 3D positions? No, it takes 3D positions, which I'm just using 2Ds, not 2Ds, I'm just using 2 dimensions for. So I don't know why this doesn't work. I mean, let's try one more. Make it really big. Yeah, that's just 0% working. Okay, fine, moving on. Draw AA convex polygon. And we're going to do the same trick that we just did to get the normal vector. And I promise to make this better later. So this is 2 minus from. We use both of them. So new vector 3. Oh wait, hold on, this is params vector 3, so I'm going to go from middle. The bump is going to put it out horizontally, so we also got to back it up a little bit. So if I know, so what I'm going to do here, let's get the parallel vector, and if I know that these both are normalized, I don't need to normalize the result. Let's just do that and see how this looks. Middle plus bump. Oh, it's going to put it on the other side, which is not quite what I want. Middle plus bump minus parallel times 4. And then middle minus bump minus parallel times 4. I'm going to put this within the wire color section too. Okay, so this should draw me a little triangle. There we go. Got little baby triangles on there that are just not in the right position at all. Okay, right. I gotta add the scroll position and scroll anchor to these. So I'm gonna make middle just include that, and then I don't need to do this here. Cool, there we go. Now I really want some of these things to be slightly forward. I got myself some nice little arrows there. Check that out. It looks pretty good. So now I know which way my transitions are going. They're a little small. I mean, I could make them bigger. See how this looks. Nice. I like how it does this little piece in the middle here too. If they're bumped far enough apart. Actually, that's a little confusing as to direction because they're not longer than they are. Yeah, let's make these a little longer. And then I need to bump them further apart as well. That's unfortunate.
Either they don't know, don't show, or don't care about what's going on.
If I'm going to do something that the Unity editor doesn't do, which I wish it did. Which is, I'm going to make it so that the lines are only bumped if it has a transition going both directions. Which means you have to look through every single transition. So we definitely know that the transition goes that way. So we just need to look through the transition to see if there's one that goes backward. So transitions out. look through this list and just look for a transition that goes in the other direction.
I want that shit to come back to haunt you.
Okay, so we only do the bump if you have a reverse. Actually, which means that we can just do this here. If that, then bump and return. Otherwise, do that. Okay, look through all the transitions in the destination state and see, yeah. See if any of them are reversed. If so, we do the bump. If not, we don't do the bump. Wait, that's not good. So something definitely got messed up there. Oh, right. Bam. There we go. Nice. Okay, then for my last trick, I'm going to snap these positions. Am I going to do that? Is that what I'm going to do? You know what, let's see how it looks. I bet that's not going to look good for the double. It might look good for the single, though. I want this editor to be super satisfying to use. I mean, because I'm going to be using it all the time, so. Oh, interesting. It's placing it up there because the center point includes the title. Let's not do that. Let's not do that. So do I want the center point plus how big is the title? So this is Harmony Editor Utility Title Rect. Get note title rect. This thing is a single line height. Just make sure we're grabbing the same value here and not just duplicating the reference. Okay, so now from and to will not include the title height. Down is up and up is down. That's much better. I mean, is that halfway on this one? I feel like... Is it snapping? Is it the snapping? It might be the snapping. This seems insignificant, but this is one of those things that it would just bother me forever. Like every time I'm using it, it would be something that I would be like, ah, I really wish that were different. Oh, it's actually going too far because now it's not actually halfway on this, it's to the bottom. Oh. That'll do it. And this way maybe I don't need to snap. Move it up a little. There you go. All right. And yeah, I would need to, I could not snap if I made these things vertically correct. I mean, how does this look with a tiny one? Let's just see what it looks like if I snap these. Yeah, it does get a little high on that one. I think I like it though. But why does that look weird? I think because that looks right, this looks wrong because it's one extra, but the snap should be to the half grid when you're doubled. Oh, that's confusing. Okay. Do I care? Do I care about this? How much do I care about this? Not that much. We're gonna leave it. So like, I have the power to line things up if I want to. I just need to make things the correct size, basically. And then, there we go. So that's nice and everything is lined up. Okay, cool. So I got little arrows going. I got, they need to, probably should be colored correctly when I get that thing selected. Draw. So this is drawing the extra transition expression stuff. That's the that little connector wire, which I think I want to make that connector wire a little squiggly, just to show that it's not, you know, an intentional. I don't know, that it's not a transition. It looks pretty okay as it is, but I'll figure that out next. Right now, I think I want to turn this little draw convex polygon in the middle piece into something that's actually part of drawing a transition. So instead of draw edge, I have to draw transition. I need to move this into here. Shoot. I know what I can do. Since I can't move that in there, I'm going to say bool has reverse as a parameter, and then bool selected as the last parameter. So this is basically just going to get those points. So I can do a version of this. Yeah, I can do this. I'm going to do a version of this that just takes in the data it needs and then gets called externally. So rather than doing this search in here, I'll just do this search elsewhere and pass in the data. So I can say from state to state in here, and bool has reverse. There we go. Then if has reverse, then we're going to do this bump. Cool. Now we get to do this in here instead, which is just call header utility dot get editor transition points for from state to state. And we also do this little search in order to get the value of has reverse. It's false. And break here. We can even do this, so we don't need this if statement here because we're already doing a different conditional. Say reverse equals this expression, and then well, not has reverse and there's something left in the list, then we just return this. So we say out from out to from state to state has reverse, and now bam, this function has been extracted so that it can be called here from draw transition using the data that we get passed in here. So basically, I mean, this is just going to make the exact same function call. And that way I can extract this draw procedure and call draw edge, which will correctly understand the selected state. Right. What do I call this thing? The anchor. Always need the anchor. And then to this piece, say that's the anchor. Yeah, this is a, so 2vector2 is a GGEZ thing that I have. So it's just, all it does is just do this. It's an extension. Part of one of the libraries I use is something that I created called LabKit, which Harmony is eventually going to be released as a part of LabKit, but it essentially just it has a bunch of boilerplate in it, and it's all things that Unity should have built in, but for some reason doesn't. So stuff like, hey, I need to take a vector3 and convert it into a vector2, or man, I'd love to know the closest point on this line from this other point. Like, why isn't this stuff in there? I don't know. But anyway, it's in LabKit, so you can go grab LabKit on GitHub. And pretty soon you'll get to mess around with Harmony yourself too once I get that stuff uploaded. So, but I'm going to make this piece at least not rely on lab kit entirely. Bump V3. Why is that? Oh, right, because the next line. So truly that's the half width. And then we have another couple float constants here. Triangle. The arrow forward. Oh shoot, I did the wrong thing. This is parallel times arrow forward. And then parallel times arrow backward. There and there. Okay, so that'll draw our little triangle. Just gonna label this. Draw the triangle. The thing that it doesn't do is set the color based on selected properly. So that's being done. Holy cow. No. Draw edge. Selected. Draw Bezier. Bezier. Selected. Ah, here we go. So if it's selected, it has a different width, but I'm not going to change the size of the arrow. So this, I think I just need to do the handles color thing. So save the old color. Set the new color to selected. If so, selected color, otherwise wire color. And then set the handle color back. I really hope draw a convex polygon is a fast function. I mean, I know it's building triangles in the back end, but it's got to be fast, because otherwise, well, I mean, just rendering an interface, it's not that big a deal. I can always clamp it to just render the stuff you can currently see, but none of this stuff feels efficient, that's for sure. Yes, I know about 2vector2. Where am I still using it? Oh, I'm using it here. Oh, that's not going to work. I have to normalize it first, so I can't avoid the extra multiply. That's okay. This constant is a half separation. Okay, and then when I do, yeah, it is confusing. Right, we're not identifying the fact that, are we not? Is get editor transition points not, oh, it's not returning here, so else we do this. There we go, that's why. Okay, so it should still draw the same way. There we go, great. Okay, we're back to drawing those. However, what I want to do is use this fancy new piece here. I'm going to bake this into, no, I can't. Okay, I have to say pool get editor. Okay, from state to state has reverse equals get transition, or editor transition has reverse. And now I'm going to know if it has the reverse or not, which I can also use this when I finally call. We're almost there, folks. The point where I draw the transition using the new data has selected. Away we go. Harmony, editor, utility, draw, transition from state to state, which I need to just grab from here. Again, this is all over the place. Got that. From state to state has reverse selected. And the anchor, as always, is these two. Okay, that takes care of that. Now, if all goes well, we'll get the exact same thing. I love when you write code and the purpose is, it does the exact same thing, but differently. Oh, but it doesn't, why is it not highlighting my, oh, hold on, it's because I have a compiler error. Middle does not exist in the current context. Oh, right. It would really like to know where the middle is in order to draw that line. Which, I mean, I can do. So this get transition points, I guess, can't go away completely. Shoot, and I deleted middle again. I think it's getting to be about finishing time. There we go. Okay, from to middle, got all that. Old color, I don't care about because that'll be automatically reset now, unlike it was before. So, stays the same. Right, those things don't have a color. Ha, there we go. Now when I select it, everything changes. Very nice. That's exactly what I wanted. So I got that piece in, and so now I can't see this little squiggly line coming from here because I changed the colors. So let me put these colors back. Specifically for drawing these pieces. I'm wondering if I should draw that handle using a little Bezier. I mean, because depending on which direction these states go, I'd have to figure out. Basically, I just want it to be a normal off of it, or like a 45-degree normal off of each of those pieces, and the opposite one on top, because I want it to be a little S-curve. I think it's gonna be cute. So, okay, yeah, because when states are, ooh, that's kind of. There's, oh right, it's the same thing. I gotta size it properly to line these up. Okay. So if I draw this using Draw Bezier, then it will take care of the colors for me. So let's do that instead. So let's say Harmony Editor Utility, Draw Bezier. So Draw Bezier is, it really just calls into the handles function here. but I wrapped it in such a way to make it a little bit easier to understand, because for some reason, and maybe somebody can explain this to me, it might just be, I guess, the way a Bezier is parameterized, but the start and end tangent are not tangents, they're positions. Who knows? I don't know why they decided to do it that way. So even though it says tangent, not a tangent. So I made a version of Draw Bezier that actually does take tangents. Okay. You know, but ironically, in this case, I think I actually want the version... I might want the version that takes positions rather than tangents, because the positions are going to be... I'm just going to end up using the positions anyway. So, let's see. I want to draw... Right, the expression anchor is 1 point. The other point is middle. This one takes direct points, right? So I don't have to pass it an anchor. So from tangent, let's say nope. I don't know if this is going to work. Let's just find out. Selected. This one is... Hopefully I'll eliminate this pretty soon, but at least make the wire disk show up now. Ah, well, that's different. I suppose the expression anchor needs to be offset by scroll position plus scroll anchor, as usual. Okay, so now that'll stick on there. Right, I think the trick with this is I'm going to want a custom one anyway. And I don't think these are doing anything yet, just because they're not, the tangent isn't big enough. Hey, there we go. There's a little something. Now, that one's trying to go down on the from. Yeah, I'm gonna have to compute some stuff to make this work. So I think I'm gonna take a break and maybe come back later this evening and pick up where I left off here. So it's been fun hanging out with you guys. If you enjoyed the stream, yeah, feel free to just follow along. We'll be hopefully streaming a couple times a week, and